Hello, everyone. Today we are starting chapter 6, and we're starting with interior and exterior angles of a polygon. So, first of all, we need to define polygon is the closed figure in a plane with at least three sides that are segments. The sides intersect only at their endpoints, and no adjacent sides are collinear. So, the names of our polygons, most of these I assume you know. Three sided is a triangle. Four-sided is a quadrilateral, and that's what we're really going to focus on this unit. Five is the pentagon. Six is a hexagon. Seven is a heptagon or septagon. Eight is an octagon. Nine is a nonagon. 10 is a decagon. We skip 12, or skip 11 and go to 12, which is a dodecagon. They all have names up to, I don't know, probably 100-sided or more. Anything beyond 12, we're really just going to call an engon, where we replace n with the number. So a diagonal, so if I start with the pentagon, a diagonal connects two non-consecutive vertices. So in my pentagon, that would be a diagonal, that would be a diagonal. We could go this way with a diagonal. Anything that skips a side or a vertice. Convex has no diagonals with points outside the polygon. So that pentagon is convex. That's what we're used to. There is concave that has at least one diagonal with the points on the outside. So a concave pentagon with like that still has five sides. But if I draw this diagonal, it's on the outside of the shape. Generally, concave will form a cave. So I want you to pause and I want you to do an activity where you're going to pick different figures and you're going to sketch them. And then we're going to identify the number of sides and the number of triangles. Now, when we're forming our triangles, if we stick with our pentagon, we pick a vertice and draw as many diagonals as you can. So our pentagon, I can draw two diagonals, which forms three triangles. So pentagon, five sides, three triangles. And I want you to do that for several. So pause and do that for several. Okay, so I filled in mine for heptagon or pentagon, hexagon, heptagon, octagon, decagon. Hopefully you see that the number of triangles is always two less than the number of sides. And when I'm doing the sum of my interior angles, I multiply 180, which is a triangle, times the number of triangles. So I get 540 for a pentagon. 180 times 4 gives me 720 for a hexagon. 180 times 5 gives me 900 for a heptagon. 1080 for an octagon. And 1800 for a decagon. I'm sorry, that's wrong. 1440 for a decagon. So our theorem is, which you must memorize this, the polygon angle sum theorem is for any engon, where n is the number of sides, it's n minus 2 in parentheses times 180. So we can do some examples. So when we're finding the sum of the degree measures in an interior with 100 sides, we're going to use our formula, n minus 2 times 180. We can substitute 100 for n, so it's 100 minus 2 times 180. And I do that on my calculator. And I get 17,640. Now, to find x, we know that this is a pentagon. There are 5 sides. So that means the interior sum, n minus 2 times 180, is 5 minus 2 times 180, gives me that the sum is 540. So since the sum is 540, I do 115 plus 105 plus 117 plus 100 plus x equals 540. And I solve that on my calculator. And x equals 103. So I want you to pause, and I want you to try doing these 3 where we're looking for the sum of the exterior angles. Now remember, an exterior angle is one angle drawn at each vertex by extending the line. And it doesn't matter how you extend it, we're going to extend 1. And I want you to find out what the sum of the interior angles in all 3 of these are. Okay, so I extended all the vertices so that I had one exterior angle at each vertice. I found their measurements by knowing the fact that they make supplementary or linear pairs. And then I added them all up, and no matter what my shape was, the sum was 360. Therefore, the polygon exterior angle sum theorem is the sum of the exterior angles with 1 at each vertex is 360 degrees. So it doesn't matter what the polygon is, the exterior angles add to 360. So I want you to pause, and I want you to try to do 3, 4, and 5. Okay, so hopefully you paused and did these. Number 3, find the sum of the measures of the exterior angles of a polygon with 36 sides. Again, the exterior angles, I don't care how many sides, it's 360 degrees. Number 4, to do this problem, we need to remember that a regular polygon has all congruent angles and all congruent sides. So that means to find the exterior angle, one exterior angle, I take 360 and divide it by 20, which is 18 degrees. So one exterior angle is 18 degrees. Now to find the interior angle, I have 2 options. I can use that information about an exterior angle and know that it's always supplementary with the interior angle. So I did 180 minus 18 is 162. Or I could use my interior angle sum theorem, which is n minus 2 times 180, and divide it by n to find one angle. And so that's 20 minus 2 times 180 divided by 20 gives me 162. Find the number of sides of a regular polygon. Again, that means all sides and angles are equal, each whose exterior angle contains 120. So an exterior angle, they add up to be 360. So I did 360 divided by 120, means I have 3 sides or a triangle. So again, pause and try 6 and 7. Okay, so for number 6, again, there are 2 different ways I can do it. I'm talking about a regular polygon, so all the angles and sides are equal, whose interior angles contain 160 degrees. So that means each angle is 160 degrees. So option 1 is I can use the interior angle sum, n minus 2 times 180, and divide it by n, which would give me each angle equals 160. I cross multiplied, got 180n minus 360 equals 160n. Solve that, and n equals 18. The other method is I can note that the interior and exterior angles always are supplementary. So I did 180 minus 160 to find out that 20 degrees is an exterior angle. I then did 360 divided by 20 and got 18 sides as well. Number 7, the sum of the measures of the angles of a polygon is 2,880. And I need to find out how many sides. So here I have to use the interior angle sum theorem. So n minus 2 times 180 equals 2880. I divided both sides by 180 and then added 2, and n equals 18. So that is the end of our notes for today. If you have any questions, please ask me in class.